We are working through 5.1.5.2. It should not be terribly difficult. Okay, operations with functions and composition of functions. We've actually done stuff similar to this before, so by the time we're done, you're going to be able to add, subtract, multiply, and divide functions, and then we're also going to be able to compose new functions. Okay, so starting out, you don't have to write anything down. This is just what we're going to kind of see. This right here means add the two functions together. Sorry if it's kind of blurry. There's also in your textbook if you wanted to look at it. So this second one here, f minus g of x, that just means subtract them, okay? And so on. So this means multiply, that means divide. You're going to be given two functions, and you're going to be doing these operations with them, okay? So starting out down here, given the function f of x and g of x, find f plus g of x. So all that means is I add the two functions together. So I'm going to write this one out. So 3x squared plus 7x. And I'm going to add it to this function, which is 2x squared minus x minus 1. And then it's very simple from here. You just combine like terms. Everybody should be good at combining like terms. So I add the x squareds together. That'll give me 5x squared, so those are taken care of. I'm going to add my x's together, so I have a 7x and a negative x. That's going to give me plus 6x, so those are taken care of. And then I have a negative 1 on the back end. So that's it. So f plus g of x is that, 5x squared plus 6x plus 1. Okay, just for the sake of time, this one's fairly simple. I'm not going to have you guys add another one. We are going to look at a subtraction one, though. So we have the same functions from the first one, except now we're subtracting. Okay? This makes a little bit more of a difference with that negative here. So I'm going to show you how you should write it out. So I want to take this function minus this function. Okay? So I got 3x squared plus 7x, and I want to subtract this whole function. So you should put the second one or whatever you're subtracting into parentheses. Because what do we need to do now that there's a negative that's crunched in front of the parentheses? That means you're going to have to distribute that negative through there. Okay, or you can just think of subtracting each term. Okay, I think distributing the negative makes it a little bit easier, a little bit more mindless. And then we can just kind of add pretty much. All right, the parentheses are gone now that I distributed that negative. So now we're just combining like terms again. So 3x squared minus 2x squared is just an x squared. 7x plus x, that's an 8x. And then plus 1. Okay, so we subtracted those two functions. So f minus g of x is that, x squared plus 8x plus 1. Okay, so we're going to skip the addition one here. Don't do this. I do want you to try a subtraction one down here. Okay, so please pause the video and have students work through problem example B. Okay, so shouldn't be too bad. We're doing f minus g of x. That means we're taking this function and we are subtracting this function from it. Okay, you needed to make sure you used parentheses or you changed all the signs in the second function when you subtracted it. All right, so that's f of x. We are subtracting g of x. So when I'm subtracting that function, I need to distribute my negative through there. Boom, boom, boom. So rewrite that so that way we can see all the sign changes. Oops. So plus 5x plus 2. Now we got a negative 3x squared minus 3x plus 4. Combine like terms now. So 2x minus 3x squared, or 2x squared minus 3x squared, the negative x squared. That's that one and that one. And then 5x minus 3x is a positive 2x. So used up those. And then we have 2 plus 4 is a 6. So plus 6 on the back end. So hopefully we all got that answer. Shouldn't be too bad. So we're just subtracting two functions. Okay, so we covered addition and subtraction. Next we're going to cover some multiplication. So this little dot here, you guys should know that that means multiplication. Another way to write this would be f of x times g of x. Okay, same kind of way. Same kind of deal there. So we are going to be multiplying two functions. So if I just write it out as I see it, 3x squared minus 2x plus 1, that's my f of x, times g of x. After I write it out and set it up, it's kind of like a FOIL situation, okay? And I've asked you guys before, but which one do you think we should multiply into the other? It's best to take the little one into the big one. Now, there is no one way to do it, but I think it just works a little bit better with organizing. So we're going to take the little one here and multiply it into the big one here. So take the x and run it through. We'll get a 3x cubed minus 2x squared plus an x. And then we take the negative 4 through there. Okay, so that would give me a negative, let's write it down correctly. So I have a negative 12x squared, which goes underneath my other x squared term, minus or plus 8x minus 4. So combine like terms, 3x cubed minus 14x squared plus 9x minus 4. So that's what we get when we multiply the two functions together. Okay, so hopefully that made sense. It's not too bad. We've done plenty of multiplication before. All right, so we're going to use those same exact functions and we're going to divide. Okay, so we're not actually going to take the time to do long division or synthetic division. It's even easier than that. So if we're doing f of x over or divided by g of x, we're just going to write out one over the other. 3x squared minus 2x plus 1 divided by x minus 4. That is it. Okay, that's all you're going to need to do for division. We do need to kind of, since we have division with a variable in the bottom, we have to kind of think of this. Are there any numbers that cannot be in the domain? Any numbers that you cannot plug in for x that would potentially ruin the equation? Okay? And what I mean by ruin the equation, think of if we had something like this, 1 divided by a 0. If you punch that in your calculator says, can't do it, cannot divide by 0. Okay? Is there anything here that would give us a 0 on the bottom? Okay? Should be fairly straightforward. If I plug a 4 in down there, we would get a 0. So my excluded values, I have to say x cannot equal 4. So I have to list that excluded value with my division problem. Another thing you could see is if I had something like this, where you're never probably going to have all 2's like that, but if they're all even numbers or all odd numbers or something like that, then you can divide the 2 out of everything. That would be the only other thing that you could do to simplify. So this would turn into something like this. That would be it. Okay? That's just if you ended up with something that had all even numbers. Okay, let's try a couple on our own. So given that function, f of x and g of x, find f times g of x. And I'll just slide this down. We'll do both of them at once. So please pause the video, have students work through these two examples, and then resume so they can see the solution. So for f times g of x, we have 2x squared plus 3x minus 1 times quantity x plus 2. Multiply those two together. So the x goes through there, and we get 2x cubed plus 3x squared minus an x. Now the 2 goes through there. So that's going to give me a 4x squared plus a 6x minus 2. Combine like terms. 2x cubed plus 7x squared plus the 5x minus 2. That is it. Down below, we're doing division, so you're just going to write f of x over g of x. And really, that is easy enough. The thing that's a little bit more difficult that you have to remember, domain restrictions. What can I not put in the bottom? Okay? My domain restriction here would be x cannot equal a negative 2, because that would give me an undefined problem. So those are your answers for those two problems. That is, we now know how to do addition, subtraction, multiplication, and division. So the next thing we're looking at here will be the last thing for the lesson. We're looking at composition of functions. Okay, so composition of functions. Think of a function, this is the f of x stuff. Composition of function is plugging the value from one function into another function. Okay, it can also be plugging one function into another function to create something new. Okay, so this right here is really truly what we call composition function because you're creating a new function. All right, so we're going to be looking at something like this. We are given the function f of x and g of x and h of x. Okay, we could use one of those, two of those, or all three of those for function composition. Okay, so really what we're looking at for a here, we're looking at is, so the way you would read it would be f of g of 4. Okay, so if we kind of think of it just like this, so forget about the f for now. G of 4, you guys should totally be able to do that. Okay, so g of 4, that means I'm just plugging in a 4 into my g function, so it'd be 3 times 4, which is 12. Okay, but we have f of g of 4, so this is now going to be in the place of that g of 4 there. So really we're looking for f of 12 because we did the g of 4 already. Okay, so f of 12, so my f function is the 2x minus 1. It would be 2 times 12 minus 1. So that would be 24 minus 1, which is 23. Okay, so f of g of 4 is a 23. Okay, so we should be able to do the next one. I'll kind of work through it slowly, try to kind of keep ahead of me, see if you can figure it out. So we're doing f of 6 first, so we look inside first, and then you work out. So f of 6, that means we're plugging 6 into the f function, so it'd be like this. That's going to give me a 13. So 12 plus 1 is 13. So then we're going to do g of 13. Okay, so we find our g function. It's just 3x up there, so it'd be 3 times 13. So that's 13, 26, 39. So f or g of f of 6 is 39. Okay, a couple more down below here. So this is actually function composition here. We have g and a little dot there, h, and then x. So this right here, that little dot, the open circle there, that's function composition. So I'm composing. I'm g, I have function g compose h, all right? So the same way to write that is this, g of h of x. All right, and we always work inside out, just like I said on the last one. So we're going to take the h of x function there, and we're going to plug that into my g function, okay? So h of x is x squared plus 1, and g of x is 3x. So we're going to take this stuff here and plug it in for the x. So it would look like this. So we'd have 3 parentheses x squared plus 1. So we're plugging the h function into the g function. All right, and then we just distribute and simplify it as much as we can. So 3x squared plus 3. That right there is g of h of x. So I composed the new function, 3x squared plus 3. For the next one over here, for d, we're going to do the same thing. We're taking the f function, and we're plugging it into the h function. Okay? F is 2x minus 1, and h is x squared plus 1. So we're taking f, that 2x squared plus 1, or 2x squared minus 1, 2x minus 1, excuse me, plugging it in for the x of that function. So that means I'm putting 2x minus 1 in parentheses, and I'm writing it squared because that would be plugging in for that x there. And that's what it would look like after I plug it in. Okay? So again, I took the 2x minus 1, and I'm plugging it into the x of the h functions, because we're doing h of f of x. Okay? So this right here is not just going to be 4x plus 1. It's a FOIL. Okay? Don't make that mistake. We got to FOIL that out. So if you remember the pattern, it would turn out to be this after I FOIL it. Or you can just write it out twice and FOIL it out, okay? So 4x squared minus 4x plus 1, and then we just have to simplify it from there. So 4x squared minus 4x plus 2. That right there is h of f of x. Okay, I composed the new function. It's 4x squared minus 4x plus 2. Okay, let's try a couple more of these, see if we can figure them out. All right, don't worry about this one down here. Forget about it. It's a hot problem. That means higher order thinking, so that means it's a little bit harder. So I want you guys to try to do the 3 problems that I have here. Try to work through A, B, and C. So please pause the video and give the students a little bit of time to work through these 3, and then press play again and it'll go through the solution. Okay, so for A, we're doing g of 18 first. All right, so let's plug an 18 in there. So 18 minus 9 is a 9 inside there. Square root of 9 is a 3. So we're going to do f of 3. And my f of x function is the 9x minus 9, negative 9x, excuse me. Plugging the 3 in there, minus 9, so this will give me a negative 27, minus 9 is a negative 36. So this one equals a negative 36. For B, remember I said that that little operator there, that means function composition. So that's the same as doing this, f of g of x, where I take the g function and plug it into f. Okay, so g is the square root one, and we're plugging that into f. So it looks like this, negative 9 square root x minus 9 with a minus 9 back there. And we haven't worked a whole lot with square roots yet, but you can't do anything from there, okay? You cannot distribute into a square root, you would just leave that out front, and since we have that subtraction sign inside there, you can't do anything to simplify the square root. So that right there is just your answer. It looks kind of goofy, but that would be our answer. Okay, because we took the g function and plugged it into the f function. And then the last one down below, C, we're doing g of f of 2. Okay, so remember that little dot operator there? That's just a different way to write it. So this would just be written as g of f of 2, like that. So we do f of 2 first, and then we plug that into g. All right, f of 2 would look like this. So that would give me a negative 18 minus 9, so a negative 27. So that's what we're plugging into the g function here now. Okay, so we would have square root negative 27 minus 9. All right, so that gives me a negative 36 underneath there. Square root of negative 36. And we can simplify that. We know the square root of 36 is 6. And a negative underneath there gives me an I. So this would give me a 6i if I were to simplify that down. Okay? So hopefully the function composition stuff makes sense. If you need some extra help, you can go to YouTube or you can go to our textbook resources. If you just type in function composition in YouTube, you'll get a ton of videos. Okay? Here's your homework for the assigned sections here, so 5, 1, 5, 2. Try to work through these. Let me know if you got any questions. All right? Good luck.